everyone, I'm teacher Bojan from Kangaroo Study. Welcome back to our channel again. Now, today we're going to continue our Math Olympiad adventures by looking at this new topic. This is what we call the area and perimeter. So, let us take a look at the question together. So, the figure below is made out of 5 squares. The perimeter of the small square is 8. Find one side of the bigger square. Now, to make it easier for us to address the squares, let's label them from the first to the fifth. The first being the smallest, the fifth being the biggest. So let's compare the neighboring ones first, the first and the second. Now compare between these two. Are we able to find the relationships between one side of the square? So we can see this is quite difficult. You know why? Because they have different orientations. One of the square is pointing this way, the other is pointing this way. So it's difficult for us to compare one side of the square. Now, how about the first and the third? Everyone will notice. Now, these two, they are pointing in the same orientation. So, both of them are in this direction. So, let's extract the squares first. Let's see if we can find the relationships between one side of the square. Now, from what we learned before, if two figures are exactly the same, so we know that one side of the figure will be the same also. Suppose we have two identical squares. Then we know that one side of the two squares are the same. Now, if we also have two identical triangles, what can we say about corresponding side of the triangles? Very good, everyone. Those are also the same. So in this figure, we can see that we already have some triangles. Now, are we able to make the whole figure into small triangles that are of the same shape? We'll notice that we are able to use the cutting method to do that. And how can we do that? We can just connect the diagonals here. Now, after we connect the diagonals in the figure, it's all small triangles. These triangles, they all have the same shape. Now, let's find those along one side of the big square and the small square. So, along the one side of the small square is the green triangle. Along one side of the big square is the pink triangle and the orange triangle. Now, are we able to find this one side of the triangle? We are able to do that. Because the question tells us the smallest square, the perimeter is 8. So let's find one side of the smallest square. How do we do that? Very good, everyone. We can just use the total divided by 4. Because in each square, we got 4 sides. And those 4 sides are all equal to each other. So 8 divided by 4. We find one side of the smallest square is 2. Let's label it here. So if this side of the smallest triangle is 2, how about the pink and the orange triangle? What's one side of those triangles? Very good. Those are also 2 because these 3 triangles, they are identical to each other. So now we have found one side of the third square. This is 2 times 2. So that's 4 cm. Now let's compare the next square in the same orientation. Also pointing this way, that will be the bigger square. So we compare the third to the fifth. So again, we can extract the squares. The third, the fourth, the fifth. And how do we do the comparison? Good. We do the same method. We can cut the diagonals again. So by connecting the diagonals, we cut the figures again into small triangles. And for each of the small triangle, you can see the longer side here is 4 cm. So for one side of the bigger square, how long is it? Very good. This will be 4 times 2. So now we find out the answer is 8 cm. So now we have solved it by using the cutting method and compare the first, the third, and the fifth. Because for these squares, they are in the same direction. Now let's try to solve the question using a different method. So this time we compare the adjacent squares. Now between the first and the second, if we compare these two, so we will notice that we cannot compare one side of the square directly. But how about the area? Area. We will notice that if we want to compare the area, we can still apply the same method, which is the cutting method. So we cut them into small triangles of the same area. Let's connect the diagonals of the small square. This way we cut it into 8 small triangles. Now the first square contains how many small triangles? Very good. This contains 4 small triangles. How about the second square? How many triangles does it contain? We notice this 8 triangles. So 8 triangles, 4 triangles. we can see that the second square is 2 times of the first square. So now, from the second to the third, let's compare between these two. So again, let's extract the squares. Now, how do we compare between them? Oh, perfect! We can do the same method again. We can do the cutting method. So let's connect the diagonal. Now, after we connect the diagonal, we can see the second square contain how many small triangles? Good. This contains 4. Third square contain how many triangles? Very good. This is 8. So 8 and 4. This is 2 times of the number again. So we can notice what's the pattern here. Every time we have a new square, this is 2 times of the previous square. So let's find area of the first square. Then we are able to find area of the last square. So the perimeter is 8. We can find one side of the square is 8 divided by 4. One side is 2. Now we get area of the first square. This will be 2 times 2. That's 4 cm squared. Now, in order to find area of the fifth square, how many times do we need times 2? So let's check. From the first to the second, times 2. Second to the third, times 2. Third to the fourth, times 2. The fourth to the fifth, times 2. So altogether, that's 4 times. So let's take the number 4. Okay, times 2, 4 times. Times 2, times 2, times 2, times 2. So we find the area of the bigger square is 64. Now, if area of the bigger square is 64, what's one side of the bigger square? Oh, we know, right? We can use the square numbers. This is 8 times 8 equal to 64. So one side of the square is 8. We get the answer again. So let's do a summary on these two methods here. Now, in the first method, what we did first is we identify those squares that are pointing in the same orientation. Those pointing in the same direction is easier for us to compare the side. Now, when we are finding the relationship between one side of the square, what method did we use? Perfect. We use the cutting method. By cutting them into small triangles, we are able to find the relationships. In this time is 2 times. Now, in the second method, we didn't compare those in the same orientation. We found the neighboring squares. So instead of comparing one side of the square, first we convert the perimeter into the areas. Or we compare area between the neighboring squares. And when we compare the areas between the neighboring squares, how do we find the relationships again? Oh, very good, everyone. We again use the same method, which is the cutting method. Now, by cutting them into small triangles, we can compare the area relationships. Now, after we get the area of the bigger square, what do? We convert the area back into the perimeter, and from the perimeter, we can find one side of the bigger square. So after we are clear about this question, let me give you this practice question. It's very similar to the question we did just now. So once you figure out the answer, you can post it in the comment section, or else you can add my contact here. This is my WeChat and WhatsApp contact. You can scan the QR code and add me on WeChat or WhatsApp, and then we can discuss the solutions together. Now, if you want to get the most updated information on the events that are held in our center for the GP preparation and Math Olympiad trainings, make sure to join our study groups below. So once again, if you want to receive more awesome videos from us, make sure to hit the like button and subscribe to our channel. So until the next time, peace out.